All right, today we're looking at section 4.2, getting started with that. But before we do, we're going to look at a couple things that we've talked about recently that are going to apply to what we're doing today. Remember that capital F of x is the antiderivative of f of x. So that means that the derivative of the capital of f of x equals f of x. So just keep in mind that notation. And also, what we talked about the past couple days is if we take the antiderivative of the derivative, those are inverse operations. They kind of cancel each other out. But in this case, when we take the integral last, right, we would have to take the derivative of this first and then take the antiderivative. We end up with f of x plus c. So if we take those two things together here and look at this next part, we're going to start to look at some new rules and how to integrate and take the antiderivative. A couple people asked this in class the other day. You know, we had a bunch of different rules for derivatives, like one of them was chain rule. Do we have some type of rules for antiderivatives? And that's kind of what this is, what we're talking about today. Change of variables and indefinite integrals. Really what we're doing today is generally called U substitution. And this is just what we do to take the antiderivative of things where we had to use like the chain rule to get the derivative. So basically, it's the opposite of the chain rule. Kind of undoes the chain rule. And you kind of see it here a little bit. So, according to what we talked about over here, if we take the antiderivative of the derivative, we're just ending up with what's inside of here plus c. So we would get capital F of g of x plus c. Now, let's look back here, kind of go back to chain rule. What is the derivative of capital F of g of x? Right? That is something we would have to use chain rule for because we have an inside function and an outside function. So if we take the derivative of that, remember it's just the derivative of the outside, so derivative of capital F of g of x, that inside stays the same, times the derivative of the inside. All right, that's just our basic chain rule. So, building off of what we've talked about already, if we have the antiderivative of the derivative of f of g of x, that's the same as the antiderivative. If we go ahead and do the derivative of this, we just did that right here, we have derivative of capital F of g of x times the derivative of g of x times dx. All right, going back to what we talked about up here, remember the derivative of capital F of x is just regular f of x. So right here, derivative of capital F of g of x, we can write that as the derivative, I'm sorry, not the derivative, but just f of g of x times the derivative of g of x dx. Now, you can see this is looking like a pretty complicated mess right now. Got a lot going on here. So what we're going to do is to try and simplify this a little bit and make it a little less congested. So what we're going to do is we're going to let u equal g of x. So taking place of g of x right here, this is going to become f of u. All right, so it's a little bit less complicated right there. Now, if u equals g of x, the derivative of g of x, okay, if we take the derivative of this side, we'd have to take the derivative of this side. So derivative of u, another way we can write it other than just u prime, would be du dx, because this one's a derivative in terms of x. So for this, if we put du dx in for the derivative of g of x, Kind of put this off to the side. We get du dx times dx. If we're putting that in place right here, what happens? Right, the dx's cancel out. So by doing this little u substitution, what we're doing is we're taking this big ugly mess and kind of simplifying a little bit. Right, and it kind of tells us down here a little bit of what we just said. But we have the antiderivative instead of f of g of x, it's f of u times derivative of g of x. Instead of that, we have du dx times dx. So like we saw over here, those dx's cancel out, so we can write this a little bit simpler. F of u du. Right? That is a lot less complicated than this. Antiderivative of this, remember antiderivative of f is capital F of u plus c. Now, the problems we're going to be looking at today are very similar to this. They're going to start off looking very complicated and difficult, but just by using a little u substitution, we can make it look a lot simpler and make it into something that we can do the antiderivative of. And then at the very end, we can substitute back in for u.